Hey everybody, and welcome to Chapter 3. So Chapter 3 is really where I think the rubber hits the road, and we're going to start doing some calculations. And you can see that I mean that because I broke out the stylus so that I can do things like this on the slides in real time so you can see me do math. But anyways, so welcome to Chapter 3. We are going to be talking about central tendency, and this chapter is going to be in 3 videos. The first video is going to explain central tendency and talk about some of the most common and most popular ways of measuring that. The second video is going to be about spread and variability and how to calculate that. And then I'm going to do a third video, which is going to be basically like how to do this all from scratch, where we just break down one data set and just kind of walk from the very beginning to the very end of how to analyze it or practice what we did in the chapter for this. So let's go ahead and get started. So what we're going to be looking at is talking a little bit more about statistical notation. Now, statistical notation you may remember from Chapter 1, right? We talked about summation notation, so we're going to return back to that. We'll talk about what central tendency is. You may be familiar with some of these, even if you aren't familiar with the term central tendency, but good chance you've done some of these in your math classes previously. And then we'll talk about variability and how we might want to calculate that and what it means. So let's walk through a quick experiment. So in this experiment, let's say that I ask people how much time do they spend looking at a screen over the weekend. So this could be a tablet, it could be their phone, could be their TV, their computer, whatever. So these are 1, 2, 3, 4, 5, 6, 7. So there's 7 separate people who I asked for this. I'm just breaking out my calculator already. So I sent it out to seven people, and they gave us those numbers in minutes. So previously, whenever we've looked at data, we looked at visual depictions of the data, right? And that was one way to summarize the data. Is like you look at the data and you can kind of see generally what the pattern looks like, or if there are any trends, things of that nature. This chapter, we're going to be talking about how can we express that as numbers. How can we express what the data mean? If there are any trends, how can we explain that using numbers instead of visuals? And if we use numbers instead of visuals, we can be much more precise about what we mean and what we can conclude from that data. Alright, so calculating the values are going to be only one step of this. Again, thinking back to Chapter 1, I talked a little bit about how I like to think about stats like a language, where you are speaking it, but you also need to be able to understand it and read it. And so when we talk about some of these values, like mean, median, and mode, is not just knowing how to calculate them, but also when to calculate them. You're not going to want to use all of those all the time. You're going to want to do usually one or the other. And so we're going to be looking at those different central tendency measurements and talk about their individual strengths and weaknesses. Alright, so thinking about how to describe data, how would you be able to describe what the center of your data set is? Because if I say center, there are lots of different ways to interpret the words and meaning of center. So there's more than one way to do it. So if someone asked me, how did the class do on the exam? That's one kind of question. You would probably be expecting something like an average, right? Or if somebody asked, how long do people spend on social media per day? If that's the case, those questions, or the answers that those questions are looking for, are probably best expressed in the mathematical average, or maybe they mean the middleist score. So what is the most, the score that represents the middle of that distribution? Or maybe they're going to be asking for the most common score. Which of those is the most frequent? So, if somebody asked, how did the class do on the exam? And, maybe I could say that the average was a 72. But if, let's say, most of the class got a 75, it might be in the best interest to say that, well, the most common score was a 75. So you get the idea. There are different reasons why we might be looking for one of these 3. So let's take a look at each of those. Now, before we do that, I want to talk a little bit about notation. So some of this is going to be familiar because you already know what this is. You know that that's sigma because we learned that in chapter 1. So remember that sigma means it's the summation symbol. Basically means all of the numbers, you want to add them up. So let's add up all of those numbers. Now I want to turn our attention now to this I. So the I equals 1. This is not something you generally have to worry about for our class, but here's what that means. The I basically stands for index and is looking at where in our list do we start. So if I is equal to 1, and remember that X here represents the data set, and that means that we're going to be starting with the first data in this data set, this first value, and we're going to add up all the rest after that first one. And the reason why I say add up all of them is because I'm referring to the sigma here. So the N at the top represents the total amount. So up here, the capital N refers to all of the data that are in your sample. So if I had 10 pieces of data, then this would be a 10 up here. But the examples that I'm going to be using and calculating have 7. So I would put 7 there for that case. So basically what what this means, if we're just looking at, and I'm gonna go, I'll say this in plain English in just a second, or write this out as a plain formula. But what this means right here is that for the sigma, we're going to be adding up all of the values in the data set X, and we're going to start doing that with the very first item in that data set. That's what the I equals 1 stands for. And we're going to do this for all of them, which is what the capital N up here means. So we're going to add up all of the values in the data set. Then we are going to divide by the total number of items in that data set. Alright, so that is called the mean. It is also probably known to most Americans as the average. But the reason why people don't call it the average is because when we say average, maybe we mean that it's the most common. And if that's the case, average and common mean two totally different things to us. So we're going to use the phrase the mean. The mean is what you're going to, anytime we talk about average, I'm always going to call it the mean. I don't want to call it the average because we just don't do that in math and stats. So in order to get the mean, you're going to add up all the values together, and then you're going to divide by the total number of values that are in that data set. So it would look something like this. This is mostly, this is how you would most commonly see it expressed. You'll note that you don't see the I equals 1 here, and you don't see the N up here, and that's because we're going with the basic assumptions, and we're always going to assume, unless we see otherwise, that I is equal to 1, and that the value at the top there is the total number of values in your data set. For our class, you're never going to see those in different. So if they're not there, you can just assume that I is equal to 1. Alright, so basically this means we're going to add up all those values, and then we're going to divide by the total number of values. And so if you see this over here, this Greek value called mu, that means it's for a population. If you see it with this value, which we are going to call x bar, that is for a sample. So these two things mean two totally different things in stats, and that seems kind of weird because you may say, like, wait a second, how is the mean of a population different from a mean of a sample? Why do we need two separate values to express the same thing? They're the same thing, aren't they? They're actually not, because the mean of a sample is an estimate. The mean of a population is a value. And basically the difference means that x bar, when you see x bar, it means that that is a rough estimate based on the data that we have. Mu means that we know the average, or we know the mean, and this is what it is. Alright, and we'll talk more about those ideas as the semester goes on, but there's a reason why we are writing these out as separate things, even though they seem to have the same formula. Alright, so returning back to our experiment here, if we wanted to add all of these up, that would give us 397 plus 432 plus 872 plus 427 plus 388 plus 782 plus 397. We add all those up, and that gives us 3,695. So what do we do next if we want to get the mean? we're going to take 1, 2, 3, 4, 5, 6, 7, and we're going to divide that by 7. So that gives us 3695 divided by 7, and so that gives us an average or a mean of 527.9. Now, if we want to be extra specific, we're going to say that that is actually x bar is equal to 527.9. Why is it x bar? Because this comes from a sample. I did not ask every single person how much screen time they use. So that's going to be x bar. All right, now let's look at the median. The median, which again is probably familiar to a lot of you, the median is the middlest score, which means that if you were to arrange all of the values in your data set from smallest to largest, you're putting them in an ascending order, that the median is going to be whichever value is right there smack dab in the middle. So you lay them all from smallest to largest, the one right there in the middle, that is going to be your median. The median is also the 50th percentile. Remember back to chapter 2, we talked about percentiles, and we talked about, the upper 25th percentile, the bottom 25th percentile, and so on. The median is going to be the 50th percentile. In other words, any value that falls below the median is going to be in the lower half of the data. Any value above the median is going to be in the upper half of the data. So the median is always going to be the 50th percentile. So if we wanted to, we could use the same formula that we looked at in chapter 2 to find the 50th percentile, but generally in order to do that, you're going to have to arrange all of the numbers from lowest to largest anyways. So it feels a little bit like it might not be a super good use of time to do it that way. So the median is tricky because if you have an odd number in your data set, it's easy. The median is right there in the middle. But if you have an even number of entries, then it gets a little bit more complicated because you don't have a middle value. You have two values that are close to the middle, and the way to get the median then is you're going to add them up and then divide by 2. In other words, you're going to get the mean of those two numbers, and that'll give you your median. So if we look at this example, we're going to arrange this from smallest to largest number. So we're going to go 397, 397. What's the next one? 427, 432. Oh, did I mess up somewhere? Oh, yep, I did. Oh boy, because why did I write that out? My bad. 388. 397, 397, because there is a second one here, right there. 427, 432. Did I mess up again? Which one am I missing, y'all? $427. 432. Oh, I didn't. Okay, sorry, I didn't screw up. I thought that I did. Sorry for that. I freaked myself out for a second. Usually I would edit that out, but I wanted to leave that in just to show you it's okay to second guess yourself. Go with your gut, because oftentimes your gut is correct. All right, so here we have 7, and if I would, one way to do this is whenever I'm doing this on my own, I like to write all of them out and then just start crossing this one, lowest, highest. Lowest, highest, and that gives me whichever one's left in the middle is the median. And I already typed that stuff out anyways. I was just trying to be interactive. So if we were to go through, because it is an odd number, it is going to be the one in the middle. Now, if we took out one of those, so we took out this one right here, so what is it now that we have 6? We're going to add up these two in the middle, so 397 and 427. We're going to add those up, and then we're going to divide by 2, which gives me 412. So if you have an even number like this, you don't have a middle value, you're just going to get the mathematical mean of this right there, and that gives you now 412. So we would say that our median here is 412. All right, now let's talk about mode. So mode is the most common value in the data set. The reason why it is called mode is because it means fashion in French. So another way to think about this is that the mode is the number that everybody wants. Everybody's using it. So it is the most common one. And I put a picture of pi here, basically because whenever people talk about pi a la mode, they mean pi of the fashion, because back in the day it was seen as like a fashionable thing to get your pie with ice cream. Because it is delicious. Let's not kid ourselves. So this is going to be whichever value occurs the most in your data set. It occurs the most frequently. Now, this seems easy, but again, we can make it complicated because sometimes you might have more than one mode. And so what happens if you have more than one mode? Let's say that you have two that are tied for being used the most. If so, we call that bimodal. And a bimodal data set is a really tricky beast and one that we're not going to talk too much about this semester. But essentially, your data would look something like this, where you have, your typical x-axis and y-axis is going to look something like this, which is hard to analyze. And if you do get something like this, you're usually not going to get the average, or the mean, because if you do, the mean is going to give you whatever value this is, which is not super informative for your centralmost item. You're usually going to want to refer to this piece and this piece, which would be your two separate modes. All right, so an example here. So using our friendly example, we're going to look at ordering it from smallest to largest. I like to do that, ordering it from largest to smallest, just so that way it groups the numbers together. And so if I do it this way, then I can see that 397 occurs twice, therefore it is our mode. So I mentioned at the beginning of this chapter that there are some times we want to use one central tendency but not the others. So here's where that will come into play. So we might measure compare central tendency values. For example, if we're talking about the U.S. income, these values reflect, I believe, where I pulled this from, I believe that they were using pre-inflation values, so to take it with a grain of salt. But the mean income in the U.S. is about $72,000. The median income is $59,000. Why? That seems like a huge difference, right? Like, I would love to make $72,000. $59,000 is good too, really good, but I would much rather have 72. That's a $13,000 difference, and that is a huge amount of money. So why? Why is it the case that these two values are totally different, even though they should be giving me that center value? That's what we're here for, right? Is the central tendency. So the mean is really, really, really easily influenced by large or small values. So any value that is in an extreme can easily influence the mean, but cannot easily influence the median. Any kind of value that you have that's going to be very large or very small, we're going to call those outliers. Outliers is one of those terms that has kind of become, it's kind of leaked into kind of popular conversation or mainstream conversation. So you may have heard it on the news, or when people talk about data or research, they talk about outliers. So outliers are going to be those extreme values. If you are worried that your data might have extreme values, then you want to usually go with the median. So here is an example for why it influences the mean. So in this data set right here, we have a distribution that looks essentially kind of like this. And that looked like it was going up. I didn't mean that. It looks something more like that. Here, our median is closer to over here, but our mean is over here. Why? Because we have this guy over here making $710,000, and this lady over here making $475,000, making way more than her or him or her or him or her. So they're these are way so far down the scale that when we add up all these values, these two values greatly increase that sum score compared to what we would have normally gotten here. So sometimes some researchers like to exclude these values, but generally speaking, unless you have a really good reason to, you can't do that. And so that's going to greatly increase the mean here, where it's actually closer to down this way, our true center value. So that's one case where you might want to use the median instead of the mean. And that is all that I want to talk about for this video. For the next video, we're going to start talking about variability and spread. So I will see you there. Bye-bye.